Welcome to the deep dive. Today, we're plunging right into the core of, well, pretty much every computer out there. The operating system, the OS.
Mm.
Think of it less like just the brain, maybe more like the absolute foundation of its security.
Yeah,
Get a crack there, and everything else built on it can just crumble.
that's a great way to put it.
We've got a whole stack of sources here, and we're going to unpack exactly why the OS is so fundamental for cybersecurity.
Yeah, and what's really fascinating, I think, is that the OS isn't just, about keeping things stable. It's the ultimate trust boundary.
Trust boundary, okay.
Right. Everything else, your critical apps, your data, it all hinges on the OS's integrity. If that gets compromised,
But it doesn't matter what else you have running.
pretty much, it can subvert the whole system. Other security measures become almost, well, irrelevant at that point.
So, okay, if the OS is this bedrock, where does that foundation really start? Our sources kept pointing to the kernel.
Yeah.
It's the absolute core, right?
That's it. The kernel.
Okay.
It's the central, really low-level part of the OS.
Low-level meaning.
Meaning it talks directly to all hardware, and critically, it runs in what's called kernel mode,
Kernel mode.
which basically means it has ultimate control, direct access over everything.
Ah.
And that design, that power, is both its greatest strength and, honestly, its biggest security vulnerability. It's the #1 target for attackers.
That feels like a huge paradox, doesn't it? The thing built for total control is also the ultimate weak spot if someone gets in.
Exactly.
So how do attackers even try to get at something that fundamental? What are their main strategies based on what we saw?
Well, the big one is privilege escalation. That's the name of the game.
Trying to get more power on the system.
Precisely. They want to gain root privileges,
Mm-hmm.
full admin control. And our sources had this really stark example. CVE 2025-38236, a Linux kernel exploit.
Okay, what happened?
Get this. An attacker managed to break out of a Chrome web browser sandbox,
Out of the browser safety zone.
right out, and gain full kernel control over the Linux system underneath.
Wow, just from a browser issue.
It shows how just one flaw, in how the kernel manages resources fundamentally can lead straight to a complete system takeover.
That's like something out of a movie. Escaping the sandbox to own the whole machine.
So it really begs the question, what's our defense against something that high level?
Yeah.
Because it feels like the really scary stuff must be these complex, hidden, zero-day attacks nobody knows about yet.
And that is scary, but it's a bit of a misconception, actually. Our deep dive showed something maybe more mundane, but just as critical.
Okay.
The single most important defense against kernel exploits. Robust, regular patching, and good patch management.
Just updating things.
Sounds simple, right?
Mm.
But so many successful attacks exploit known vulnerabilities, flaws where a patch is already out there.
So it's like leaving your front door unlocked, even though you know the lock is broken and there's a replacement sitting right there.
Exactly that. And alongside patching, we absolutely rely on the principle of least privilege.
Making sure users, applications, everything only get the absolute minimum permissions they need to do their job. Nothing extra.
Right. It's sobering, isn't it? Focusing maybe too much on the exotic stuff and missing the basics.
It can happen.
And it's not just about these deep kernel exploits, is it? What about vulnerabilities closer to, our everyday use, things that aren't necessarily bugs in the core kernel itself?
You're spot on. While the kernel is, the ultimate prize, many common breaches aren't 0 days. They often come down to simple human error, misconfigurations.
Like setting something up, right?
Exactly. And of course, failing to patch. Attackers love abusing misconfigured permissions, like exploiting SUID binaries.
SUID, set user ID.
Right. Programs that are set up to run with higher privileges often root privileges no matter who actually runs them.
Ah, okay. So even a normal user could potentially run something as root if it's misconfigured.
That's the risk. And our sources gave a really practical example. An attacker could use a totally legitimate command, something like find.
The search.
Yeah, the standard find command. If it has a misconfigured SUID bed, an attacker can leverage that to get root access.
So your own system tools turned against you because of a setup mistake.
Yeah.
That's a real eye-opener.
It shows how attackers often use what's already there, these everyday tools, for privilege escalation. And it's not just OS components either. Application flaws can ripple out.
How so?
Well, take buffer overflows. Classic vulnerability.
Where a program tries to write too much data into a small space.
Exactly. It writes beyond its allocated memory buffer. You might have, say, a simple strap-A function in some C code.
The string copy function.
Yeah, if it doesn't properly check the size of the input first, An attacker can feed it oversized data, overwrite crucial program memory, and potentially hijack the program's execution.
Leading to system control again.
Potentially, yes.
Yeah.
Hijack the program, make it run malicious code instead.
Okay, but surely there are defenses against that kind of thing now.
Oh, absolutely. Modern operating systems have gotten much smarter. They use techniques like ASLR.
Address space layout randomization.
Right. Shuffles memory locations around, makes it harder for attackers to know where to jump, and DEP, data execution prevention.
Stopping code from running in places it shouldn't, like data areas.
Exactly. These make those classic overflow attacks much, much harder. Not impossible, but harder.
So, wrapping this part up, what are the key takeaways for defense against these more common issues?
Look, at the end of the day, it comes back to fundamentals. Robust patch management is still number one.
Keep things updated.
Keep things updated. Plus, continuous vulnerability scanning, using strong access control models like RBAC, role-based access control.
Assigning permissions based on roles, not individuals.
And hammering home that principle of least privilege again and again. These aren't fancy, but they are incredibly effective.
So, looking back at everything we've dug into today, what really stands out to you, for me, it keeps coming back to that kernel paradox. Its incredible power is also its greatest potential weakness.
Yeah, that's huge. And for me, it's also the fact that so many real-world successful attacks aren't about some super complex, brand new exploit.
Right.
They're about known flaws, preventable issues, simple misconfigurations, human error, really.
So, the big picture then. The security of your entire digital life, it really is only as strong as that OS link in the chain.
It really is. But the flip side is, often that link is something we can strengthen proactively with these fundamental security practices we've been talking about.
We've tried to give you a shortcut today, a way to get well-informed on OS security from our sources. Maybe think about this. What specific steps could you take right now to harden your own systems based on what we discussed?
Yeah, what's one thing you could check and update today?
Definitely something to consider. Until next time, keep digging deeper.